This video outlines the recommended steps to install and align your polar clutch system. Proper clutch alignment is required to ensure safe operation, maximum performance, and consistency as the primary and driven movable shifts cycle from idle to high gear. In this video, we will use a polar Quickshift clutch system and half-scale motor plate. Installation and alignment is straightforward using these components. The steps shown in this video can be applied, however, to any polar clutch system or similar clutch requiring a 5/16 inch offset installed on any motor plate. You will need a clutch alignment tool designed to ensure that the driven clutch is offset 5/16 of an inch from the primary. You will also need an assortment of shims to fit the 3/4 inch jack shaft and a caliper to measure shim thicknesses. Suggested part numbers for alignment shims and a sketch for the toothbrush alignment tool are provided at the end of this video. We'll begin by installing the primary and driven units. You will also need 3/16 inch keys for both and shims or spacers for installation behind the clutches. For the primary unit, you'll need a hardened steel washer with a step machined on the crank side to accommodate the crankshaft radius. The clutch side of the spacer should be smooth. If any aluminum was previously transferred from the primary post, the washer should be lapped with emery paper to remove aluminum buildup. It's a good practice to apply a small amount of never-seez to the crank snout. Be sure to remove any never-seez residue from your hands to prevent contamination of the clutch sheaves. Next, install the primary clutch key and then slide the primary unit onto the crankshaft. This particular installation uses a hardened threaded stud, ASTM A193 grade B7, along with a grade 5 nut, hardened washer, and a grade 5 nylock. These high-integrity fasteners are highly recommended when a drum lock is not used. Our Quickshift primary comes standard with a drum lock, so the double nut arrangement is optional. A grade 5 or grade 8 bolt with Loctite may be used in lieu of the hardened stud. Never use mild steel all-thread or lower grade bolts to secure the clutch, even if a drum lock is used. The driven unit may be removed several times throughout the alignment process. For an initial mock-up, install enough shims or spacers on the jack shaft to extend just outside the motor plate stand. A good starting point is approximately 300 thousandths of spacers. We may add or remove spacer thickness later to achieve proper clutch alignment. We really don't need the driven key right now, but we'll put it in for demonstration purposes. Then, we'll install the driven unit. If a jack shaft support is to be used, install the spacer, ensuring there is adequate clearance for the helix bolts. Then, install the jack shaft support bar and enough outer shims or spacers to achieve a minimal amount of float. We will remove shims later to permit some driven float. Note that this arrangement assumes an end-bolted jack shaft will be used. Racers wishing to use locking collars can modify this procedure accordingly. The original polar alignment tool has a slot that fits over the movable driven sheave. The opposite end of this tool has a plate that should just contact the inside edge of the fixed primary sheave. Similarly, the Halfscale tool contains a groove that sits over the inside edge of the movable driven sheave, while the slot in the opposite end fits over the fixed primary sheave. The alignment tool brush sits between the sheaves and is therefore independent of sheave thicknesses. This tool is preferable when mixing and matching primary and driven units from different manufacturers. A sketch for making this tool is provided at the end of this video. While these alignment tools will yield slightly different shim or spacer requirements, they will all provide a safe and reliable alignment setting with compatible primary and driven units. We'll now put these three alignment tools to use. Setting the original polar tool into place on the driven movable sheave, we can see that our initial driven shims are very close to the desired 5/16 inch alignment. The tool suggests that a small amount of shim could be removed from behind the driven unit. The Halfscale tool yields a similar result. Some driven shims could be removed, but the current alignment is very close. To use the toothbrush tool, snap the small end between the driven sheaves with the wide end facing outward above the primary post. Proper alignment is achieved when the large end is centered across the post. This tool indicates that the driven requires additional shim. We'll continue the alignment procedure using the toothbrush results. we're going to remove the driven, add 60 thousandths of shims, and replace the driven to recheck the alignment. Now the tool is centered across the primary post, indicating the correct alignment between the sheaves. Note that it is possible to install a clutch system with the driven unit too far inboard. This is particularly true on some older motor plates with narrow jackshaft stands. Here is an obviously misaligned condition. Significant misalignment, which can be detected with any of our clutch tools, may cause the primary post to seize onto the crankshaft, reduce crankshaft life, and in severe cases cause the belt to jump over the primary fixed sheave, potentially creating a sudden, dangerous lockup condition. In order to establish some float on the driven unit, we'll remove 60 thousandth shims from inside and outside of the driven. This will provide approximately 1/8 inch of float. If desired, more float can be achieved by removing additional shims in equal amounts from both sides of the driven. Our float allows the toothbrush tool to move across the entire width of the primary post. If using a jackshaft support, install the support assembly, verifying that the support plate aligns squarely with the jackshaft support bar. Ideally, the primary support plate will be centered over the drum lock bearing. Half of the bearing is considered the minimum recommended coverage. If necessary, a spacer can be placed behind the primary support plate to keep the assembly aligned while maximizing drum lock bearing coverage and also maintaining the driven float. Note that it may be necessary to move driven shims from outside to inside the jackshaft support bar. Finally, verify that the jackshaft support bar clears the helix bolting with sufficient clearance at the outermost float point. If multiple driven shims were used during the alignment process, it is a good practice to measure the total thickness for each stack of shims and to make individual spacers for both the inside and outside of the driven unit. This minimizes the possibility of installing the wrong spacers, especially during quick pit work. At a minimum, consider color coding the spacers with paint stick or equivalent to be sure that the right spacer goes in the right place. Now we can perform the final assembly of our properly aligned polar clutch system. Remember to recheck the alignment if changing to a new primary or driven unit, if the motor plate is changed, or if moving the clutch system to a new motor plate. Some racers apply a drop of Loctite to the driven and primary fasteners. Loctite on the primary side is highly recommended if a drum lock is not used. Your polar clutch system has been designed, manufactured, and configured with attention to detail at every step along the way. Proper clutch alignment will help you maximize the safety, reliability, and performance of your clutch system. Thank you, and good luck to all of our polar clutch customers from Halfscale Dragsters.